For this first exercise in the array chapter, we're going to demonstrate how to use the array as a way to keep track of the number of occurrences of a random number when we loop through a random number generator. You'll see what I mean once we develop the program. The first thing I'm going to do is create our random number generator. Then I'm going to create a variable to store a random number in. We'll call it num. I'm going to create a constant for my array, which is going to be 101. And I'm going to create the array. We'll call it numbers. It will store the occurrences of the numbers as we come across them. And here's where we begin that process. So we write a loop that starts at 1. We don't want to store anything in position 0 because the numbers we're generating are going to be 1 through 100. And then we'll write while I is less than size, plus I. And then in the loop, the first thing we do is generate a random number in the range of 1 to 100. And then use the number generated as the index into the array, and then increment the value stored there by 1. When we initialize numbers right here, the values that are stored in numbers are going to be all zeros because it's an int array. So every time we come across a number, so for example, let's say the first number generated is 50. We're going to index into the 50th index position and increment that value 0 by 1 to be 1. So that will keep track of the occurrence of the number 50 in the list of random numbers generated. Then if the next number is 22, then we're going to index in the 22nd position 22 and increment that value by 1, and so on and so forth. When we're finished, we can just write another loop, and of course I could have methods for this, but that's okay for this example. A standard loop through the array. Write out the current value of I plus a colon, and then the number of occurrences of that number in the array. So let's run it and see what we get. So looking at the bottom of the display, we'll see that 100 was generated twice, 98 once, 97 twice, and then we can scroll back through all the other numbers. 1 was not generated, 2 was generated once, 4 was generated once, 5 and 6 were both generated twice. I'm not going to display a list of the numbers generated. You can certainly do that in this program. Let's run it again, but that's just going to take away from what I'm trying to demonstrate. Here's another list. Let's do it again. And there you see another set of lists. This time we didn't begin generating numbers till number 4. There were no 1s, 2s, or 3s. But notice the randomness of these lists. Every time the occurrences change. This time 1, 2, and 3 were generated once, twice, and once respectively. So there's a fairly decent distribution of numbers over the range of 1 to 100. Now in the next exercise, we're actually going to take this idea and change from a numeric display to a histogram, where we're going to draw a very primitive bar chart of the number of occurrences using asterisks to represent. If there's 3 occurrences, then there'll be 3 asterisks. If there's 5 occurrences, there'll be 5 asterisks, and so on. And we're going to see how to do that in the next exercise. In this next exercise, we're going to take the program we just wrote that displays the number of occurrences of numbers through the random number generator and change that from numbers to a bar chart or histogram to give a graphical display. Now this isn't perfect since we are working with a DOS window, but you get the idea of how you can use this sort of technique for some fancier graphics displays, and it gives us a chance to work with arrays some more. So here's the previous program, and to change from numbers to a histogram is really a fairly simple change. So here's what we're going to do. First I'm going to create a variable, stars. It's going to store the number of stars or asterisks we're going to write when we create a bar chart for a number. Then taking the for loop that we already have, we'll open up the body. Go ahead and delete this line because we're not going to use it anymore. And then write stars is equal to numbers sub I, and that'll be the number of occurrences for any particular number that shows up in the list. Then we're going to write the first prompt, which is the number and a colon out beside it. Then we're going to write an inner loop. This is almost more an exercise on working with for loops than it is with arrays, but you get the idea. Then for j equals 0, j less than stars. So if stars is 3, then j will go 0, 1, 2, plus j. Console right, an asterisk. A console right line, empty line, to put a space after the last asterisk, or a blank line. So there's our complete program. So the outer loop is taking us from each number, from 1, 2, 3, 4, 5, 6, all the way through 100. Then the inner loop is going to write out the number of stars that represents the number of occurrences of that number. So let's give this program a run. So there you go. Let's scroll it up so you can see a little bit better. So there was 1, 1. There's no 2, 3, 4s or 5s, and 2 6s, 3 7s. Scroll down. There's 3 56s, 4 66s, 4 75s, and so on and so forth. Let's run it again. Okay, this time, of course, we get a different distribution. But again, it's very nice to be able to simply look at the stars or the bar chart to figure out the number of occurrences. And in the proper environment, this would be a very useful display. It's a little bit clunky here, again, since we're working with a DOS window. So to summarize what we did, this was a very simple change to the program. We already had the basic outline in place. All we had to do was add an inner loop that wrote out an asterisk for each number of occurrence. So if there were 3 occurrences, then we wrote 3 stars, or 3 asterisks. So that inner loop is what's doing the work in this particular program. So this was a pretty short exercise, and that's probably good because the next exercise is going to be a little bit longer. We're going to see how to use a two-dimensional array to simulate shuffling a deck of cards. For the last exercise of this chapter, we're going to demonstrate how you can simulate shuffling a deck of cards using a two-dimensional array. We'll start out by writing the methods, and then we'll go back and write the top-level program. First thing we need is a method to initialize the deck of cards. So what we're going to do is we'll pass in a parameter of a two-dimensional array. In this case, we can use literals for the number of rows and columns, since for a deck of cards it will always be the same, 4 rows and 13 columns, to represent the 4 suits and the 13 denominations in each suit. So our loop will run 4 rows, 13 columns, as I just said. And what we'll do is we'll initialize each position in the array to a 0. That will represent a card that has not been assigned a denomination or a suit yet. As we go through the shuffling process, that will take a random row and column and then assign a card number to it. So it's almost like we're taking a position and then assigning a card number to it rather than taking a card number and assigning a suit and denomination to it. It's kind of like we're doing it backwards. So the initDeck method is simply to initialize the deck to all zeros, the two-dimensional array. Then we also need a displayDeck method to look at our result, or just to look at the deck anytime we want to view it. It will be also fairly simple. Just nested for loops that display the card information. And that's just a console write with the array element and a space. And then a console write line when we're finished with one row or suit to take us to the next suit or row. So those are the 2 simple methods. Now all of the really hard work will come in this third method, which we're going to name shuffle deck. It also will take a two-dimensional array as its argument or parameter. So we're going to start off with 2 variables for a row and column. Then we're going to create a random number generator. Then we begin a loop. This loop is going to represent each card in the deck. So we're going to go from 0 to 51 to represent the 52 cards. First thing we do is we generate a suit, and they can be in any order you want. We are not representing the order here. You can start with hearts, diamonds, then clubs and spades, or you can start the other way around. It doesn't matter. That's not the point here. Then we generate a random number to represent a denomination. And again, there is no necessary stating of the rank from low to high. So ace could be low or ace could be high. Of course, we know that the other cards are already in their order. And then a program that used this deck would have to make that determination. So then, after we've generated a random number for the row and the column, then we check to see if that position is open. In other words, is its value equal to 0? If so, then it can be assigned the card value. So for example, if we hit row 2 and column 2 and it's equal to 0, then that's going to be the first card in the deck. It just depends on what the random number generator generates. If it's not equal to 0, then we write another loop, a while loop, that looks for a 0, a cell or a row column position that's 0. And to do that, we generate random numbers again. And then when we get to a row column that is equal to 0, we assign it that card value. And that should take us through the program. So once again, there's the shuffle deck method. Now we're ready to write our top level program. So the first thing we're going to do is create a couple of constants. And we're going to initialize our two-dimensional array that stores the deck. We'll call it deck with rows and calls. Then we call the initDeck method with deck as the argument. Then we'll display the deck just to verify that it is all initialized to zeros. Then we'll call a console write line right here. Then we'll call shuffle deck to shuffle the deck, and then we'll display the deck again. And then we have a console read key to hold our screen open. So that's it. Again, let me emphasize how using methods makes your main program so clean and easy to read. And that's one of the reasons we write methods to start with, is to make the main program easy to read so that we can ignore details if we don't care about them. Then if we care about them, we simply scroll down to the method definitions and take a look. All right, so let's run the program. There's our initialized to 0 deck, and then here's our deck with the 52 cards assigned. So row 0, column 0 is card 1. So that can be a 2 of hearts, or however you want to start with the denominations and suits, and that would be how it works. Let's do it one more time, just to see that we'll get a different deck every time we shuffle. And then let's do it a third time, just to verify. So this is a very good example of how to use a data structure, such as a two-dimensional array, in a quote-unquote real-world program, or in a real-world situation, shuffling a deck of cards. And with that, we've finished this chapter on arrays, and we're ready to move to the next chapter where we talk about different alternative control flow structures you can use in C#.